Let's talk about numbers for a second. Numbers are kind of a weird thing because sometimes we have numbers that we know off the top of our head. Like, for instance, we know that there are 12 things in 1 dozen. Those are exact numbers. We know that 1 dozen would contain 12 something like eggs, or we could have a dozen apples or something like that. Um, and those are exact numbers. We know we have exactly 1 dozen if we have exactly 12 things. However, another example of that would be like if I have 1 inch, that's going to be the exact same thing as exactly 2.54 centimeters because that is a known conversion factor. So exact numbers are things like conversion factors that I know for a fact exist. Okay? But when we are in the lab, we do not generate conversion factors. What we generate is a measured value. And in a way that we indicate how specific and precise that measurement is with something called significant figures. And so the way that we record our numbers is something that you should look back to in the measurement video that previously. But the way that we measure will dictate how precise we represent our numbers, and those are called significant figures. And so the more significant figures in a number, the higher the precision in that number. So we're going to talk about some basic rules in significant figures. So rule number 1 is the easiest one. In significant figure rule number 1 is this: all non-zero numbers are significant. Okay, so what does that mean? Well, I'm going to show you this down here. If I have a measurement, let's say I get my meter stick out and I measure with my meter stick that it is 2.45 centimeters. And that's my measurement that I write down in my lab notebook. This guy right here has 3 numbers in it, and I'll get my little highlighter out here. This one right here is a non-zero number, so it is significant. The 4 is also a non-zero number, so it is significant. And that 5 is a significant number because it also is to the right, or is a non-zero number. So this measurement that I have here is precise to what we would call, let me write that in a slightly different way, 3 significant figures. Okay? Something like this number would have, let's say, 45,231 miles, let's say. That's a lot of miles. But that number right there has 1, 2, 3, 4, 5 non-zero numbers. So therefore, it has 5 significant figures, and that's how we would record that. So the first one is the easiest rule of all of them. Okay? The second rule is about zeros. And so what I like to call this rule number 2 is the significant zero sandwich rule. And what that means is any zero that's sandwiched in between 2 other significant numbers is also significant. And so I can summarize that by saying sandwiched, oops, misspelled that there. Sandwiched zeros are significant. And I'll just put sig for significant. So I'll illustrate that down here. So for instance, the number 504 inches. Let's just go through the rules here real quick. This 5 is a non-zero number, so it is significant. This 4 is a non-zero number, so it is significant. Both the 5 and the 4 correspond to rule number 1. This 0 is sandwiched in between two significant figures, so therefore it is also significant. This would have 3 significant figures. Okay? Now, let's talk about a number like this, 10,000 and 10, like that. 10,010. So 1 is a non-zero number, 1 is a non-zero number, so those are significant. Okay? Now, these zeros are sandwiched in between, and it doesn't matter how many zeros are sandwiched in between, both if any of them are sandwiched in between, it makes them significant. So both of those are considered to be significant numbers. Now, the question is this one right here. This 0 is not sandwiched in between them, so therefore it is not significant. It is just a placeholder. And so therefore this number has 4 significant figures. Okay, that's rule number 2. Now, rule number 3 is the most complicated of all of them. And this one requires a little bit of thinking about. And so I'm just going to write it out, and then I'll give you some examples. So all zeros to right of decimal and right of last significant figure is also significant. So a couple things here. SF stands for significant figures. And the key word here, let me highlight it because it's so important in a very bright red color here. And it's got to be both. It can't be one or the other. Okay? So an example of this would be this. 0.050, like that. Okay? So first things first, to identify how many sig figs are here, this number 5 is significant because it's a non-zero number. That's rule number 1. Then I go through each one of these. This guy right here, that is not a significant sandwich, and it's not to the right of the decimal. Therefore, it is not significant. So that guy right there is not significant. Now, what about this guy? So this one is not. I'll put an X underneath it. This one right here. This one right here is to the right of the decimal. So it's to the right of the decimal point right there. And then it's also to the right of the last significant number, or to the right of the 5. So therefore, it is also significant. This is a significant number. It indicates the precision of that measurement. Now, what about this guy right here? Well, that guy right there is to the right of the decimal. That's rule number 1 on 3. But it's not to the right of the 5. Therefore, it is not significant. This is just a placeholder indicating where that 5 is going to start. So we would say that this number right here has 2 significant figures. Okay, I'm going to give one more example like that. And this one would be 1,001.0500. Okay. So this is a big number with a lot of precision. We got 1, 1, 5 all being significant because of rule number 1. These guys right here, boop, boop, are significant sandwiches, so therefore they're significant. This one is also a significant sandwich because the 1 and the 5, this one is sandwiched in between them. That's significant. And these guys right here are also significant because it's to the right of the 5 and it's to the right of the decimal. Both of them are. And so therefore we have 1, 2, 3, 4, 5, 6, 7, 8 significant figures there. So that is a number with a lot of precision. Now, the one final thing that I want to mention here on significant figures, these are the rules of significant figures, and really that's pretty much them, okay? You can read some other places, but if you can understand those 3, this will summarize pretty much all the rest of them. The one final thing I'll mention here is numbers in scientific notation. So let's say we have like 2.0 times 10 to the 4th, something like that. This number right here, you treat it by the same rules, and you treat it by the same rules with the decimal point. Even though that's not actually the decimal point, like this number would actually be 1, 2, 3, that number right there. But you don't think of it like that. You think of it with the decimal right there because it's a way to represent really big numbers with the correct number of significant figures. And so this number right here, 2 is significant, and 0 is to the right of the decimal and to the right of the 2. Therefore, it is also significant, okay? So the reason you do that, as I pointed out, is this number could be written 2 ways, like this or like this, in scientific notation or not scientific notation. The problem is if you have to write 20,000 as having 2 significant figures, You can't do it like this. It's impossible. So the only way to do that would be to write it in scientific notation like this. So scientific notation follows the same principles as these rules. You just treat the decimal like it's right there where it indicates, and then follow the same rules. That is the basics of significant figures. Now, the next thing that we need to do is learn how do we carry over this precision in our measurements.